Why does P300 speller performance vary between users? Imagine trying to communicate using a device that reads your brain signals. Now picture how different each person's brain might respond to the same setup. That's what makes P300 speller performance vary so much from one person to another. The P300 is a positive electrical signal in the brain that shows up about 300 milliseconds after you see something important. Brain-computer interfaces use this signal to figure out what you want to say or do. But not everyone produces the same signals, and that's where the variation begins. Some people naturally have stronger or clearer P300 signals. This depends on how their brain processes information, their brain size, and how fast their neural pathways work. If someone's brain is more efficient at generating these signals, the system can pick up their intentions more easily. On the other hand, some users might have weaker signals, making it harder for the system to tell what they want. That can lead to slower or less accurate communication. Attention plays a big role too. If a person is focused and engaged, their P300 signals tend to be more distinct. But if they are tired, distracted, or not motivated, their signals can weaken. Fatigue can cause the brain to respond less strongly, which makes it harder for the system to detect the signals. This is why keeping users alert and comfortable is so important. The way the P300 speller shows stimuli also matters. The timing of flashes, called the interstimulus interval, and how long each flash lasts can influence the signals. Longer intervals give the brain more time to process each stimulus, which can improve accuracy. But if the interval is too long, it slows down the system. So, these settings often need to be fine-tuned for each person to find the right balance. Training is another key factor. Users need time to learn how to focus and produce consistent signals. The more they practice, the better their brain gets at generating clear P300 responses. Adaptive systems that learn from each user's signals and adjust over time can make a big difference. These personalized adjustments help the system better recognize each person's unique brain patterns. Age and health also influence P300 signals. Older adults or people with neurological conditions might have weaker or altered responses. For example, some neurological disorders can reduce the amplitude of the P300, making communication more difficult. Visual attention and eye movements also impact performance. Since the speller relies on visual stimuli, how well someone can fixate and attend to the flashing letters affects the quality of the signals. If someone has trouble controlling eye movements, it can lead to less reliable signals. All these factors mean that each user needs a tailored approach. Proper calibration, electrode placement, and personalized algorithms help improve accuracy. Using multiple electrodes across the scalp captures more detailed brain activity, and machine learning helps the system adapt to each person's signals. Sometimes, adding mental tasks or adjusting the difficulty level can boost the P300 response and make communication smoother. Understanding why performance varies helps researchers improve these systems. By addressing individual differences, they can make brain-computer interfaces more reliable and accessible for everyone. This is especially important for users with severe motor disabilities who depend on these devices to communicate.